This is Math 6232A 2027 trimester. So our lessons for today is about Laplace transforms. Okay. So Laplace transforms is very much important, especially if you're going to enroll with your next subject, which is all about control system. Okay. So this module is about the evaluation of the Laplace transforms functions. It is transforming the t function into the s function. Okay, so this is now the uh, objective of your Laplace transform. At the end of this module, the learner should be able to identify and derive, if needed, the different formulas of Laplace transforms. Okay. Number two, evaluate the Laplace transforms of different functions. Okay. So this Laplace transfer is very much important if you're going to have a project, which is the purpose of this one is your input should be uh, directly constant to your output. Okay. So you have your the Laplace transforms formula. So the Laplace transfer is a function of t is equal to e raised to negative st, the function of t dt from 0 to indefinite. Okay? So by this time, it's a combination of e differential calculus and integral calculus. Okay? So we have your the integral sign and we have your the function. Okay? So combination of differential and integral. So this is your lower limit and this is your upper limit. So if you're going to simplify that, is now the function of your s. So from your first uh, slides, your t functions into the s function. It is transforming the t function into the s functions. Okay? So whether your s, the Laplace transform separator, the function of t is determining function, the function of s, the generating function. Okay? So the function of t is always equal to constant, where c is equal to constant. So we have your the literal value, we have your a, b, and c. We have also the numerical value, which is equivalent to 1, 2, and 3. Okay? So this is now the summary of Laplace transforms formulas. Okay? Your constant is equal to c all over s. Okay? So your t formula is equal to 1 all over s squared. Next, t raised to n is equal to n factorial all over s raised to m plus 1. Okay? Next, we have your number 4, e. We have your the exponential function raised to a multiplied by t is equal to 1 all over s minus your 8. Okay? Next, we have your number 5 formula. Exponential again, a, e raised to negative a multiplied by t is equal to 1 all over s plus a. So take note of the sign, no? So you're negative, but in your divisor is positive. You have your positive, but in your divisor is negative. Okay? Next, another formula. T raised multiplied by e raised to a multiplied by t is equal to 1 all over the quantity s minus a raised to 2. Okay? So that's now your equivalent function. Okay? Next, number 7, t raised to n multiplied by e raised to a multiplied by t is equal to n factorial divided by quantity s minus a raised to n plus 1. Okay? So again, be careful of the exponent again. Okay? N plus 1. Next, we have number 8. T raised to n e raised to negative a multiplied by t is equal to n factorial all over the quantity s plus a raised to n plus 1. So again, be careful of the sign. You have your negative, you have your positive in divisor. Positive in the exponent, negative in your divisor. Okay? Next, we have number 9. T multiplied by e raised to a multiplied by t is equal to 1 all over s plus a quantity raised to 2. So the same formula with your number 6. But the problem here is the negative exponent. But in your divisor, we have your positive operation. S plus a raised to 2. Next, review the trigonometric functions of Laplace transform. Sine a multiplied by t is equal to a raised divided by s squared plus a squared. Cosine a multiplied by t is equal to s all over s squared plus a squared. Okay. Next, we have your number 12. Another formula. E raised to a multiplied by t sine b multiplied by t is equal to b all over s minus a quantity raised to 2 plus b raised to 2. Next, another formula for Laplace transform exponential. It's combination of exponential and trigonometric functions. E raised to negative a multiplied by t sine b multiplied by t is equal to b all over s plus a quantity raised to 2 plus b squared. So again, be careful of your sign ulit. Okay? Next, you have your number 14 formula. E raised to a multiplied by t cosine b multiplied by t is equal to s minus a quantity s minus a squared plus b squared. Okay? So next formula, e raised to negative a multiplied by t cosine b multiplied by t is equal to s plus a divided by s plus a squared plus b squared. Okay? Number 16 formula, sine x a multiplied by t is equal to a all over s squared minus a squared. Next, we have number 17 formula, cosine x a t is equal to s all over s squared minus a squared. Okay? And the last formula, e raised to a multiplied by t is equal to sine x a t is equal to b all over s minus a raised to 2 minus b squared. So this is your 18 formula for the Laplace transform. Meron pa tatlo. Okay? 19, e raised to negative a multiplied by t sine x b multiplied by t is equal to b all over quantity s plus a squared minus b squared. E raised to a multiplied by t cosine x b multiplied by t is equal to s minus a quantity divided by s minus a squared minus b squared. The last formula, e raised to negative a multiplied by t cosine x b multiplied by t is equal to s plus a squared minus b squared. Okay, next we have your illustrative example. Okay, the function of t is equal to 3 plus 3a plus 4a squared plus 4t. Okay? A is a variable, no? So by this time, we're going to transform the function of t in terms of function of s. So if we're going to look on the left side, we have your t. On the right side, we have your d ulit. Okay? So based on our discussion, we're going to make a generating function. Okay? So we're going to transform your function of t into the function of s. Okay? For this one. Okay? So the Laplace of the function of t is equal to the generating function of s. Okay? Okay. So for t, okay. So based on our formula, we have a 21 formula. Okay? So out of 21 formula, which formula is applicable in our problem number 1? So if we're going to look on our equation, we have only 4t. This is the one that we're going to transform. Okay? This one is a variable. So we have to look in your formula number 2. If we're going to convert the function of t in terms of s is equal to 1 all over s squared. Okay? So if we're going to have that one, okay? So the same function of t, Laplace, which is a function of t is equal to 3 plus 3a plus 4a plus 4 all over 1 all over s squared. Okay? So that is how your the way we are going to simplify our equation. Okay. So, bakit po meron tayong constant s dito? Because we have your 3a. A is a numerical value, literal value, and 3 is a constant value. So if we're going to look on your formula number 1, c is equal to c all over s for the constant value. Kaya nagkaroon po tayo ng constant dito, ito, then all over s. Plus, okay, this is now the equivalent function of your t into s. Okay, so for t, t is equal to 1 all over s squared. Okay, so this is now the Laplace transform of your function of t, which is 3 plus 3a plus 4a squared plus 4t is equal to 3 plus 3a plus 4a squared all over s plus 4 all over s squared. Okay, so next we have your function of t is equal to t raised to 3. So we have now exponent. Okay, so if we're going to look at our formula, that is your formula number 3. T raised to n is equal to n factorial all over s raised to n plus 1. So if we're going to apply that one in your problem number 2, t raised to 3, which means your n is equal to 3. So we're going to convert that Laplace transform, okay? So the Laplace transform of t raised to 3 is equal to n factorial all over s raised to n plus 1. 3 factorial means 3 to 1, or 3 times 2 times 1 all over s raised to 3 plus 1. So 3 to 1 or 3 factorial is equal to 6. 3 plus 1 is equal to s raised to 4. Next, you have your problem number 3. Okay? The function of t is equal to 5 plus 5t plus 5t squared plus 6t to the 4th. Okay. So the same formula that we have in our problem number 1. Okay. So, c is equal to, constant is equal to C all over S. This is now your constant. Okay. C all over S. So 5 all over S. Okay. 5t. T is 1 all over S squared plus 5. Okay. T squared is the same as your formula number 3. This is t raised to n is equal to n factorial all over S raised to n plus 1. So n plus 1, so we have your 3. Okay. 2 factorial, okay, the same as 2 pa rin, plus 6 raised to t raised to n. Okay. Our n is equal to 4. So we have 4 factorial all over S raised to 4 plus 1. This is equivalent to 5. Okay. So simplify it further. So we have 5 all over S. 5 all over S squared. 2 factorial is the same as 2. Multiplied by 5 is equal to n raised to S raised to 3. Plus 4 factorial is 4 times 3 is 12 times 2, 24 times 1 is 24. 24 multiplied by 6 is equal to 144. 4 plus 1 is equal to 5, so we have S raised to 5. So can we now continue? Next, we have problem number 4. Okay? The function of t is equal to e raised to 3 multiplied by t. So by this time, we have exponential functions. So we're going to make use of your formula number 4. Okay? So this is now your formula number 4. E raised to a multiplied by t is equal to 1 all over s minus a. Okay? Okay. So our a is equal to 3 multiplied by t. So from your formula, e raised to a multiplied by t is equal to 1 all over s minus a. Our a is equal to 3. So that is now the Laplace transform of your problem number 4. Okay. Next, number 5. Number 6 na. Okay. We don't have number 5. So the Laplace transfer of quantity negative 5 all over e raised to 3 multiplied by t. Okay, so the same formula that we're going to use. So formula number 5. So since we have here a negative value, okay, so if we're going to look on your formula number 5, e raised to negative a multiplied by t is equal to 1 all over s plus a. So if we're going to have that one, okay, number 6, our a is equal to 5 all over 3. You have your negative sign. A is equal to 5 all over 3. So your answer is 1 all over s plus a. Okay? So it's equal to 1 all over s plus a. Our a is 5 all over 3. So next, we're going to simplify it further. We're going to solve further. Least common denominator of your denominator, s all over 5 plus 3 is equal to 3. Divided by 1, multiplied by s, so we have 3s plus 5 all over t. So by this time, we have division of fractions. This is your numerator fraction, which is a whole number, or 1 all over 1, and this is your denominator fraction. Okay, so if you're going to divide two fractions, invert the fractional divisor and proceed as in multiplication. So a all over b divided by c all over d is equal to a all over b multiplied by d all over c. So following that guidelines or steps, okay, So if you're going to simplify it further, your final answer will be 3 all over 3s plus 5. So 3 multiplied by 1, so we have 3. So that's now the answer of your problem number 6. Okay? And we have the last problem. I think this is the last problem. The function of t is equal to 3 t raised to 1 all over 4t plus 2 all over 3 e raised to negative 2 all over 5t. It's a combination of your formula number 4 and 5. E raised to positive a multiplied by t and e raised to negative a multiplied by t. Okay? So your solution for positive a multiplied by t is equal to 1 all over s minus a plus 1 all over s plus a. Okay? So we have your 3. Okay? So since we have your numerical value, we have 3 all over s minus a. Our a is 1 all over 4 plus 2. Okay? 2 all over 3. So your 2/3. Okay? E raised to negative 2, 5. So this is our a, which is s plus a, 2 all over 5. Okay? So simplify it further. 3, 4 divided by 1 multiplied by s. So we have 4s minus 1 all over 4. 5. So what we are going to do here is we're going to distribute 3 in this open and closed parentheses. 3 by s, so we have 3s. 3 by 2, we have 6 all over 5. Okay? So simplify it further. 12 all over 4s minus 1 plus 2 all over. This common denominator is 5 divided by 1 multiplied by 3s. We have 15s plus 6 all over 5. So the same procedure as what we have done in your problem number 6, divisions of fraction. So we're going to invert the fractional divisor and then proceed as in multiplication. Okay? So we have 4 by 3, we have 12. Okay? So 12 all over 4s minus 1. Okay? Okay. So 5 times 2, we have 10 all over 15s plus 1. So that is now your final answer. Okay, that ends our discussion for today. It's all about Laplace transform.